This section is found in your textbook on page 383. This whole section deals with circles and things that are in circles, whether it be the radius or any other property that's going across. Some keywords are tangent, point of tangency, chord, arc, minor arc, major arc, central angle, inscribed angle, subtended, inscribed, polygon, and supplementary angles. For the purpose of this one, we're just going to look at these two right here in this lesson, called a tangent and a point of tangency. If you look at this here bicycle tire, you'll notice that there's a middle of the circle, and the bicycle tire is a circle. You look at each one of these spokes on the bicycle tire, and they're going straight from the middle out to the very edge of the circle. Okay? Each one of those spokes are exactly the same length. They would have to be for a bicycle tire. Each one of these spokes are exactly halfway from the middle to the outside, so they're halfway across the circle. That there is called the radius. And that was something that was learned a while ago. Often you'll see radius just marked with a R. Okay, looking at any circle that we have. So I'm going to take this one found on page 385. Looking at this circle that was just made, we put a dot right at the middle of this circle. And then we drew a line going straight across that's just barely touching the circle, theoretically, only in one spot. So I could do this on a totally blank piece of paper. So I'll just draw a little line here, and then I'll make a circle myself. And, oops, there we go. So there's my circle. Okay, I'll make sure that's in the middle. I probably should have drew that first, but let's go ahead and, okay, put that right there in the middle. Okay, so there's the middle of the circle. If I wanted to draw a line going across and just barely touching this here, I would have to do it something like this. So if I go like this, it's going through the circle, it's not tangent. If I do it like this, it's not tangent because it's not just touching the circle. So I'm going to move it ever so carefully, until it's just touching in here. So it's barely touching. It's only touching in this spot right here. So it's only touching in one point. Now if I were to draw the radius, and remember what the radius is, it's the point from the middle of a circle out to any point or any spot that's on the edge of the circle. So this is a radius, this is the radius, so is this, so is this, so is this. It's all the same length, just like the spokes of a bike. But if I were to go ahead and join this radius to the exact point right there, where this line, and remember what it's called, starts with a T, it's a tangent. Okay, if it's a tangent line, that means it only touches the circle in one spot. At the point where the radius meets this line of tangent, this tangent line, it's a right angle. In other words, it's a perfect corner, like on a box. See this box here? That's a right angle. That's always going to be 90 degrees. So that's 90 degrees. So, of course, this angle here is 90 degrees, where this line here and this tangent line here meet. It forms a perfect 90-degree angle. Same goes for on the other side of this line. So no matter how much I shrink this line and make it shorter, this will still be a 90-degree angle. That'll come important a little bit later when you're trying to figure out exactly in a triangle, you're trying to figure out what the three angles of this triangle would be. Okay, so as you can see, all these lines here, the only one that's a tangent line is this one right here that's going right across and just touching in one spot. And that's the point of tangency, the point where it actually touches. Okay? And this shows you in your book exactly what we just showed, that when the radius meets a tangent line, it forms a perfect 90-degree angle. So this angle here is 90 degrees. If we wanted to make a triangle out of this, at least we'd know that this is 90 degrees, even if we didn't know the other two angles. Okay, looking at an example here, what if you were given, in this circle, you were given this angle right here. You weren't given this one over here, but you were told that this line right here is tangent. In other words, it just touches this circle barely right there. Well, according to what we just learned about a tangent line, if it's a tangent line and it's connected to the radius right here at this point, it has to be 90 degrees right here. So that's 90. This is 63. And remember, in any triangle, all three angles added together must be 180 degrees. Okay, that's for any triangle. So no matter what the shape of the triangle is, all three angles will always equal, like these three angles here will equal 180. So will these three and these three. No matter what kind of a triangle I make, it will always equal all three of them together 180 degrees. Well, how many degrees do we have so far? Well, if I've got 90 degrees and 63 degrees, if I add that up, that adds up to 153 degrees. So angle O and angle A add up to 153. How much more do I need to get to 180? Well, if I just kind of take away this much from 180, I'll end up with 27 degrees for this angle right here. So as long as you know any two angles of any triangle, you can always figure out the third one. Just go 180, take away the third one, the other two, and you'll end up with whatever's left. And that's what this solution here explains. It simply says you don't know this angle, but you know this one, and you know this one. So if you go 180, take away the other two angles, you must get what's left right here. The same can be done when you try to figure out the missing sides on a triangle. And the most important thing to remember about a missing side of any triangle is that Pythagoras' theorem must be used. So I'm going to draw a triangle. And this is not just a triangle, this is actually a right triangle. And remember, Pythagoras' theorem only works for triangles that are right triangles. And the formula for that one, for Pythagoras' theorem, is always c squared equals a squared plus b squared. So all it's saying is, if you take one side and you square it, and then you add it to the other side and you square it, it will always be equal to the third side if you square it. So here's the first thing you do when you have any triangle that's a right triangle. First, you find the 90-degree angle, which is this one right here. Go straight across from it, and this will always be C side. Which one is A and which one is B? It doesn't really matter then, as long as you have A and B as these two sides and not this one. So if you're given the value for A, you just put in the number for A. If you're given the value for B, you put in the number for B. And if you're given the value for C, you put in that one. So you might be given any two of these letters. So for an example, I'll draw another right triangle and show you Pythagoras' theorem in action. Step 1. If we know this is the right angle, we go straight across and we label this C. We can label this one A, and we can label this one B. Now let's say we're told what two of the sides are. So maybe this one's 3 centimeters, and this one's 4. So let's use our formula C squared equals A squared plus B squared. Well, we don't know what C is, so we're going to leave it as C squared. Do we know what A is? Sure do. It's 4. So we're going to have to go 4 squared plus, what is B? Well, B equals 3. So it's going to be 3 squared. Okay, so I'll rewrite C squared just so I don't forget to write it. Now, can we work out 4 squared? Remember, if you have a little 2 up there, all it means is times 4 by itself. So 4 squared is just 4 times 4. 3 squared would be just 3 times 3. So 4 times 4 on your calculator will give us 16. And then we bring our plus sign down, of course. 3 times 3 on a calculator will be 9. And if we add 16 and 9 together, we're going to end up with 25. Of course, that is the value for C squared. Not just C, but C squared. Now, I don't like having C squared there. I only want the value for C. So, how do you get rid of this squared symbol? The easiest way is to do the opposite of what squaring something is. You do the square root. So the square root of C squared will cancel out the square of the C there. But of course, remember, whatever you do to one side of the equal sign, you must do to the other. So I'm going to go over here, use my calculator, and I'm going to punch in 25, and I got to do the square root of 25. And of course, on my calculator, here's my square root symbol. It's not exactly the look of that, but you can look pretty close. If I hit that square root of 25, my answer is 5. So my value for C equals 5 centimeters. So whenever you're given any triangle, and you know it's a right triangle, you can use Pythagorean's theorem, which is this simple formula up here, C squared equals A squared plus B squared, and plug in your numbers, work it out, and then you might have to square root each side at the end. Looking at this one here, in the example in your book, first thing we got to do is figure out which one is the 90-degree angle. And since we're told that this line here, CD, is tangent to this circle, then we know this line is the radius, this line is the tangent, so where the radius and tangent meet is always 90 degrees. So we know this is a 90-degree angle here, so we'll go straight across from it, and this is C. Now, which one do you want it to be, A and B? Doesn't really matter now that you figured out what C is. Now that we know where A is, and where B is, and where C is, we use our good old formula, A squared plus B squared equals C squared. And we're not solving for C this time. We already know what C is. C is 20. So we'll put 20 in for this C. And then we'll eventually do 20 times 20. We know what B is as well. So we'll put 15 in for B and do 15 times 15, which will be, if I'm not mistaken, 225. When you're done that, you'll be left with A squared, and we don't know what A is. So once you go ahead and move the answer to this all the way over here, you'll end up with A squared equals something, and then you just have the square root each side, and your answer actually is not going to work out evenly in this case. It's going to work out to 13 decimal 23. Right, so here's an example of one of the ones that was done in the notes and in textbook. If you look at something that is flying up in the air, and say this is the airplane right here. Of course, you know it's from the middle of the earth to the top of the earth, to the outside, the ground, is 6,400 kilometers. Then you've got another 9 kilometers, because that's 9,000 meters, but that's really 9 kilometers. So this is another 9 kilometers up to the airplane. So the distance from the center of the earth up to the top of the airplane is 6,409 kilometers. We don't know what this distance is from here to the horizon, or from the airplane to right there. But if we create one more line going from right there, this is a tangent line that goes from here to here, because it's just touching the horizon. So we know where that meets the radius is going to be a lovely 90-degree angle right there. Now the only thing we have left to do, since we know this distance from here to here is 6,400, then it's the same over here, because it's the same line. It's part of the radius. So this is 6,400 for this line here. This is 6,400 plus 9, so 6,409. And of course, this over here is what we're trying to find out. So let's see, where's C? Go straight across from here. This is C. And we'll make this side A and this side B. And then we just use our formula for Pythagoras theorem. Fill in all the numbers we know and solve for what we're looking for right here. Sometimes they put letters in for you already. So they put D over here. I don't like that. I usually like to scratch them out and just put in the letters A or B. Because in Pythagoras theorem, this is what they do. A squared plus B squared equals C squared. So I don't like it when they put D in there, because there's no D squared in our formula. So I usually just use the letters that are there. And you can see when you solve for this one here, and it's not D in our case, we called it A, the answer is 339.53. So the passenger is about 340 kilometers from the horizon. Okay. So just looking at some of the ones here as a checkpoint. Looking at this one here, if this is your tangent line right here, in other words, the line that's just touching the circle, this is the point where it touches. This line here is your radius, so we know this is 90 degrees right there. Okay, so this is a tangent line. This is not, and this is not. This is the diameter, and this is the radius. This one here is the tangent line because it's just barely touching. This one here is not. It's just running through the circle. Okay, that's a chord, but that's something we'll learn a little later. Looking at number 5 over here, we're told that this line is tangent to this one here, to this circle. So if this line's tangent, we already know where our 90-degree angle is. This one here is going to be a 90-degree angle because this is our radius and this is our tangent, and we know from our property of a tangent that anytime the radius meets the tangent line, it's going to be 90 degrees. So if we look at this one here, this is 90 degrees, this is 70. Altogether with two of these, that's 160. So if we wanted to guess what the third angle right here is, we just need to know, well, it's got to add up to 180, so 20 more. So this angle will be 20 degrees. Again, looking at this line, this is the tangent line right here. So we know that it's going to be 90 degrees right here at this angle right here. So we know this angle's 90. We know this is 47. Add the two of them up, and however much more we need to get to 180, that will be the third angle right here. So that's why we need to know that three angles in a triangle add up to 180 degrees every time. So here's our 90-degree angle. Here's our 23-degree angle. Add them together. See what we need left to get to 180 degrees, and that will be this angle here. Again, here's our tangent line. Here's our radius. This is going to be the angle right here. That is the 90-degree angle. Now we're trying to figure out sides. When you want to figure out sides, you're going to have to use Pythagorean's theorem. So a squared plus b squared. So as soon as you're trying to figure out some sides, you know you're going to have to use that formula. Just figure out which one is c. Well, go straight across, and you see that? Look, they tried to fool you. This one is c right here. So this one would be a, and this one would be b. So you know what a is, you know what b is, you just plug those numbers into this formula and work it out, and then you'll be left with c. Okay. So that's all these things are here. Okay. You're looking at this line of tangency, you're looking for the right angle, this is 90 degrees, and you could figure out the other angle in this triangle. So the only thing you're using the circle for is to figure out where the radius is. So once you figure that out and you know this is 90 degrees, the circles really, you kind of ignore it while you're working with the true triangles that are there. And that's pretty much what there is to this chapter in a nutshell. If there's any questions, be sure to drop me an email at mredison@hotmail.com.